Again, this is very related to what you've done before. The only difference is you're solving problems that have two unknown quantities. In grade 8, when you did stuff like this when you had a problem that involved unknown quantities, you might have been asked those problems before in grade 3 or something, but you did it in grade 3 by just trial and error or some other kind of method. In grade 8 and 9, and now again in grade 10, you do it using an algebraic approach, which is give the unknown quantity a name of a variable, and then write an equation. Or in this case, write two equations. If you have two variables, which we're going to have here, two variables, you're going to have to write two equations. So all of the problems in this section and the next section involve two variables. And you have to write some kind of equations. They're all different. I mean, there's some patterns to them and stuff, and there are some that are similar. But you're going to have to read and think about every single one. You can try all kinds of strategies like underline what the unknown quantities are, give them names. Like I've tried to give you some structure here to it. That's what's happening in section 5 is you have the structure of it asks you to identify the variables there with let statements, and then it says what's the system of equations? Two equations. If you have two unknowns, you need two equations. In the next section, none of this is here, just a big blank space. And you have to do, not just set it up, but then step 3 and 4 are going to be solve the system and answer the original problem. Okay? Anyways, there's 4 examples here, just different situations that you can try. Some of the problems are maybe kind of silly because when we start working on this, you're given silly problems that you might say, well, if you ask this question, you would already have to know the answer to ask it, so why would anybody ask this question? But you don't want to start with really complex situations the situation is beyond our grasp. We want to have situations that are simple enough that we can kind of learn the method here. And this situation says, it gives you a couple different pieces of information here, right? Here's one of them. Again, if you want a strategy to use, one strategy would be to underline or highlight or something. There's one piece of information that you know that relates the two unknown quantities. What are the unknown quantities, first of all, in this situation if you've read the first problem? What are the unknowns? How much that is and how much that is, right? If those are the unknowns, then give those make those the variables. If you're saying let C equal price of a coffee and T equal price of 1 T, okay, then you try and write the equations from that and from the information you're getting. All right. The thing I highlighted in blue there is one piece of information that relates those two quantities. You need two different things that relate those two quantities. That's one of them. Another one is the second sentence here. 4 coffees and 2 teas together cost $7.20. This part of this unit, and in fact in grade 8 and 9, is always a really tough thing for people because you have to try and translate words to something mathematical and algebraic, right? Both of these are going to involve an equal sign, but they're going to work different ways. More people would have success writing the equation for the yellow thing than the blue thing. Actually, the blue thing's not too bad either. How do you write an equation for the blue thing? If it helps, think about it in your mind first. Okay, here's the price of a coffee. Here's the price of a tea. Does it say those two things are equal to each other? Doesn't say price of coffee and tea are the same or equal or whatever. It says 2 of these are like 3 of these, right? So you could draw a bunch of them, but we don't want to do that. We want to put it into math terms, right? So we got to say 2 of these, 2 times that number, has got to be equal to 3 times that number. That's one of the equations. 2c equals 3t. Okay, that's one equation. And you can put that right over here. The other equation you might be okay writing as well. Does that one compare the two to each other? This one compared the two. It says how they compare to each other. The yellow one, does it talk about it comparing one price to the other? No, it doesn't, right? What does it do instead? It says something and something else adds up to 720, right? This kind of equation, you know, there's some kind of a sum on this side, and then there's the other variables on the other side. So it says 4 of these, 4 coffees plus 2 teas equal that, right? That's your second equation. 4 coffees plus 2 teas equals 720. If you're being really professional about it, you'd write them so that the equal signs lined up. Not that important, but if you want to impress people. As soon as you've written your two equations, you can try and start combining them. Big mistake that people make is they try to put all of this stuff into both equations they write. You got to try and separate it. Most of the problems you're working with are at least going to have the information separated into two different sentences or two different, you know, parts of the problem. Again, in section 6, the only thing you need to do, like, you know how to proceed from here for section 6. We're not going to go over section 6 together as a group, because once you've done this, what would you do after that? What would you do at this point to finish solving the problem? What could you do? Once you have your two equations, what can you do with them? Yeah, solve them. Put them together somehow, right? Isolate C or T or whatever. Put them together, find what it is, right? Okay? What was the second one here? Can we look at that? If it helps draw a picture of the thing. I realize that I didn't put the word rectangular in there, but let's pretend we think it's rectangular. How about that? Because it's talking about the length and the width. It'd be nice if it said that it's rectangular. What are the unknown things here? What things are unknown? Length and width. Right? Read through it, find length and width. You can use capital letters, little letters, whatever's not going to get mixed up with numbers in your problem. Length, width. And then you try and write your different equations. Again, big mistake that people make is they try and include all of the information that's given there all in one, in both equations. One of the things that it says is it has to have a perimeter of 26. Perimeter equals 26. That's where one of your equations is going to come from. Now, if you have length and width, and perimeter of a rectangle we said before is it's 2 of these and 2 of those, right? You can write it 2W plus 2L equals 26. But you could do it other ways as well. You could be clever and say, if the perimeter is 26 and it takes 2 widths and 2 lengths, somebody else who's really clever might say 1 width and 1 length would only add up to how much then? 13. You could do that if you want. It doesn't matter. You could write this as your first equation or this, right? It's up to you. If it's you talk about the half perimeter if you really want to. But that's one of your equations. So I'm going to put the original one because that's probably what most people would put. But what's the other equation? What's the other piece of information you're given here? This thing, right? These are the ones that people have trouble with. They have more trouble with the ones where you're comparing quantities than the ones where it's a bunch of stuff adds up to a number. Okay, they have more trouble with the ones where the variables are on opposite sides of the equal sign. This is what I would suggest to you. Start by just putting a length and a width here, and then just figure out where do I have to put the 3 to make it work. Okay? Where do you have to put the 3 to make it work? Think about it. What is it? Which one is longer? the length is longer. The mistake people make is they say, so this is the mistake. Just realize this is the wrong way to do it. This is the way people do it when they're thinking the wrong way. They say, the length is longer, so that's where I have to put the plus 3, right? Are those equal if I add 3 to the longer one? No, they're not, right? If I want to make them equal, because that's what this symbol means, if I want to make them equal, where do I have to put the plus 3? Longer one or shorter one? If I want to balance them out. Here's the length, here's the width, it's shorter. Where do I add the 3 on? To the width, right? I got to put plus 3 over here, right? Width and 3 add up to the length. That's what it says. That's your other equation. Length equals width plus 3. What's the other way you could have written that one instead? You could have written it, instead of adding 3 to that side, you could have done what on the other side? Subtract 3. Doesn't matter, right? There's lots of different ways to write them. Those are your 2 equations. You may well, in the provincial exam, they may well just, ask you a multiple choice question saying, which of the following sets of equations represents this situation? They might not even ask you to go through and solve it, right? As a matter of fact, if it's multiple choice and they want to test you on this concept, that's a better way to do it, right? Because if they just ask you the question and say, figure out the length and width, you could probably do it by trial and error without even doing this, right? But if they want to test that you know how to do this, that's probably the most common thing they'll ask you is, tell me which the 2 equations are. All right? That's what this means here. Develop a system of equations. Okay, write 2 equations with 2 unknowns to represent the situation. This is a more difficult situation because percentage is involved and interest is involved, and that causes problems for people. But I want you to think right now, first of all, if you feel like you understand the concept based on the first 2 examples. Here's the concept. Let's not get lost in the specifics of the problems that I'm using. But just think about this here. Concept is identify the variables, write the equations. Okay? Try and write 1 equation for each piece of information you're given. Let's try and do this and see where we stand here. This one's harder to see what the unknowns are. What are the unknowns in this situation? And the wording might need to be better on this because it's supposed to be, this is the total, and he's splitting it up amongst these 2 different types of investments. So he's taking $4,000 and splitting it up into, some of it's going in the lower risk one and some in the higher risk one. So the wording could be changed here a little bit, but let's make sure we understand the situation. If you're taking $4,000 and splitting it amongst 2 different investments, and then you're in different interest on each of those investments, how do you decide? What are the unknowns, first of all? What doesn't he know? What decision does he have to make? What decision does he have to make? Well, usually it's going to say at the end here, right? Develop a system of equations that could be used to determine the amount that he should invest in each type of share, right? So what are we going to call these 2 things? Sum is, whatever we're putting in the lower risk one. Amount at 5%. These are very nice interest rates in today's world. Amount at 5%, amount at 9%. This is the low risk one. This is the high risk one, right? High interest rate, high risk means you might lose money in the end. What variables would make sense there? Or you can just use X and Y if you want. You can say L for low risk, H for high risk if you want, or X and Y or whatever, it doesn't matter, right? One of your equations is easier to write than the other. Okay, I said before there's two different kinds of equations here. There's the kind where it's a bunch of stuff adds up to a number, or there's the comparison kind. The bunch of stuff adds up to a number is all the variables or both the variables are on one side and there's just a number on the other side. Or there's the kind where there's a variable on each side and you're balancing them out. What types of equations is this going to represent? One of them has to do with, it's harder to tell what the information is here. The 4,000 is definitely one of the things that's important here. What do we know about these two amounts? What's one thing we know about them? How are they related to this number here? How are they related? L plus H, what does that equal? 4,000. It adds up to 4,000, right? That's one of your equations. The two amounts add up to 4,000. Again, the wording could be fixed there, but... What's the other thing? There's this 250. How do you get 250? If something adds up to 250, would it be correct to just say L plus H equals 250? No, it wouldn't, right? Because it's not the two amounts don't add up to 250. That's the interest, right? That's 5% of H plus 9% of, or the other way around, 5% of L plus 9% of H, right? If you want to write that algebraically, 0.05 L plus 0.059 H, that's what adds up to 250. So that's the other one here. If this one doesn't make as much sense to use the other one, don't decide to turn around and say, I don't get any of this. The concept's still the same. It's you're coming up with some unknowns. Whoops, I'm scribbling. Coming up with some unknowns and then writing a couple of equations. That situation's a harder one to deal with, but that's okay. Okay, last one here is another situation that you might find slightly more difficult because it involves that distance, speed, and time thing. Distance, speed, and time. Okay, remember you've looked at that before, I'm sure, in science, and you kind of know that anyways, right? Distance, if you want to know how far you're traveling, you know the speed multiplied by the time, right? If you know you're going 100 kilometers an hour, and that happens for 2 hours, times 2 hours, you get 200 kilometers as your answer, right? The equations in this case are going to come from that situation, right? They're going to be based on distance equals speed times time, not with two P's. First of all, what are the things that are unknown here? We need to know that before we go anywhere. Let's see here, yeah. Determine the speed of the plane in still air. So this one doesn't actually name two different unknowns, but there is something else that's unknown here. This one doesn't ask you for the other unknown, but there is another thing that's unknown. We don't know the speed, but we know two different times. That's what we're going to use to write two different equations. It tells you how far it is to go there and to come back, right? But it talks about going against the wind, and then with the wind, right? Tailwind means you're going with the wind. The wind's behind you, helping you. The other way would be called a headwind. We can say against the wind. When the plane flies with this 30 kilometer an hour wind, when it flies with the 30 kilometer an hour wind, that's helping it. If we call this V for velocity, or whatever you want to call it, I'm going to say V equals plane speed in still air, right, without the wind. If you talk about plane speed, you're talking about how fast the plane's actually going. You could talk about ground speed, which would then be you're including the wind. What's the other unknown here? So we got, this was unknown. We know the time. What's the other thing that's unknown? Distance. We don't know the distance, right? No, I know in reality you could just look the distance up and it'd make the thing a lot more simple, but we're trying to learn how to use systems here, so we'll go with that. Distance traveled. Okay, let's write equation 1 from this. When you're going with the wind, what's the speed of the plane? V plus 30, right? The 30 is helping it when it's going with the wind. We don't know what D is, so we're going to put D in there for distance. And the time we're given, right? Now the thing is, this speed is in kilometers an hour, but then this thing is in minutes. So we got to put this thing in minutes into hours. I'm going to put 0.25 hours. Okay? Or you could put, if you like fractions better, 1/4 hours, right? Whatever. Quarter of an hour. And we'll just put a little note there. 15 minutes equal 1/4 hour. That's one equation. The other equation is going to look very similar, except the speed is not going to be, you're not going with the wind. So what's happening with the wind speed? What do we do here? We don't add 30 minus 30, and it doesn't take 1/4 of an hour. It takes 1/3 of an hour, right? I'm just going to put 1/3 there, but you could put it as a decimal if you really feel better about that. Right? This is just 15 out of 60. This number here is just 20 out of 60, 1/3. Okay, those are your two equations. I didn't write them on the lines, but that's what they are. If you wanted to go about solving that, you could get rid of the brackets a bunch of different ways. You could times both sides by 4 on the first thing if you want to. Right? Like, if you want to write them without fractions because you happen to not like fractions, you could take this thing D equals V plus 30 times 1/4. You could times both sides by 4, because then that'll cancel that out. You'll get 4D equals V plus 30. That would be okay to write it like that. You could even move the 30 over. That's fine. Right? You could do the same thing for the second one if you want, to clear out the fractions. That's the concept from that, from this section and the last one too. Okay? Are we okay with this? Yes, no, maybe. Let me just scroll ahead. We're not going to do the examples from that last section, but I want to skip ahead to this. I will go back there for a minute, in about a minute, okay? We're not going to do these. I'm just going to show you this last thing here. Exactly the same, except I haven't given you the kind of the framework like before, saying let this equal, what are your two equations? But you're going to be following the exact same process. The only difference here, a lot of the problems here are very similar, right? This is kind of similar to the one we just did with the planes, only it's a boat in a stream, right? When you start to do the problems that are in here, again, the only difference here is you're kind of doing all 4 steps. You're setting it up, variables, equation, but you're actually solving this and then answering the problem in the end. Okay? I put way more questions in here probably than you need. Okay? And we're getting down to crunch time here at the end of the year, so I want us to only do what we need to do, pick and choose throughout these last 2 sections so that you think you have the point. And then you're going to be good. Okay? You notice that there's no textbook assignment for this section, or even the last one. That isn't to say there's not questions in the textbook we could do,